On the morning of August 27th, 1939, a small aircraft was towed onto the runway at Maraheny Airfield in Mecklenburg, northern Germany. To the handful of observers gathered at the edge of the field, the craft must have looked like something out of science fiction, with its gleaming barrel-shaped fuselage, gaping nose intake, and stubby wings awkwardly mounted high atop its fuselage. More baffling still, it lacked the one feature every aircraft was supposed to have: a propeller. When test pilot Erich Vorstitz climbed into the cockpit and started the engine, the air filled not with the familiar drone of reciprocating pistons, but an unearthly, high-pitched screech. Then, as if propelled by magic, the aircraft lurched forward and trundled down the runway before leaping into the air. For the next 6 minutes, Vorstitz circled the airfield, reaching a maximum speed of 598 km an hour before touching back down on the runway. In that moment, aviation history changed forever as the Heinkel HE-178 became the first aircraft to fly under jet power. Within 2 decades, piston-powered aircraft would become all but obsolete in commercial and military aircraft. The jet age had begun. But who invented this now ubiquitous form of aircraft propulsion, and how did it come to rule the skies? Well, light up your afterburners and let's dive into the danger zone, exploring the fascinating history of the jet engine. By the end of the 1930s, it was becoming clear that conventional reciprocating engine and propeller technology had been pushed to its limits. On April 26, 1939, German test pilot Fritz Wendel set a world airspeed record for piston-powered aircraft when he flew the Messerschmitt Me-209V1 prototype fighter to a blistering 755 km an hour, about 470 miles per hour. This record would not be broken until 1969, and then only by 25 km an hour. At higher speeds, propeller blades begin to travel supersonically, forming shockwaves that reduce their efficiency and prevent aircraft from flying any faster. One solution to this problem is to fly at higher altitudes where there's less air resistance. However, at these altitudes, propellers must spin faster to generate sufficient thrust, and the thinner air starves piston engines of oxygen and thus power. Of course, these are partially solvable problems. For example, more thrust can be generated through the use of specially designed supersonic propellers, but even then, the speed record for propeller-driven aircraft is 925 km per hour or 575 miles per hour, set by the Russian Tupolev Tu-95 strategic bomber. Thus, for an aircraft to fly faster in a practical kind of way, an entirely new kind of propulsion system was needed, and enter the jet engine. As previously covered in our video, Was the First Jet Plane Really Flown in 1910 on our sister aviation channel, Higher Learning, the idea of propelling an aircraft using a jet of air instead of a spinning propeller is nearly as old as aviation itself. As early as 1910, Romanian inventor and aerodynamicist Henri Coanda claimed to have built and briefly flown an innovative biplane powered by what he called a turbo propulsor, which unfortunately caught fire and crashed on its maiden flight. While Coanda's claims are disputed, what is known is that his turbo propulsor was not a jet engine as we would recognize it today. Rather, it was a form of motor jet, in which a conventional piston engine drives a turbine to generate a high-speed air jet. In certain motor jet designs, fuel is injected into the jet and ignited to produce extra thrust, as in a modern afterburner. The first verified motor jet-powered aircraft to take to the skies was the Italian Caproni Campini N1, which made its maiden flight on August 27, 1940. Yet despite its innovative power plant, the N1 was unable to outperform conventional propeller-powered aircraft of the era and suffered from unacceptably high fuel consumption and overheating. And while the Soviet Union also briefly experimented with motor jet-powered fighters like the Mikoyan Gererovich I-250 and the Sukhoi Su-5, it soon became clear that motor jets were a technological dead end, and these unusual power plants soon became little more than a footnote in the history of aircraft propulsion. A true jet engine, or turbojet, is, in principle at least, remarkably simple, consisting of just 4 basic components: a compressor, a combustion chamber, a turbine, and a nozzle. Air enters at the front of the engine, where it is compressed by the compressor before being fed into the combustion chamber. Here, the air is mixed with fuel and ignited, which creates hot, high-pressure exhaust. This exhaust is then passed through the turbine before being expelled out of the engine, generating forward thrust. Meanwhile, the turbine extracts a small amount of energy from the exhaust and uses it via a connecting shaft to drive the compressor, making the whole cycle self-sustaining. The first modern gas turbine was patented in 1791 by English inventor John Barber, who planned to use it to propel a horseless carriage. Similar devices were created in 1872 by Dr. F. Stolzer and in 1903 by Aegerus Elling, the latter of which became the first successful self-sustaining gas turbine. In 1918, Dr. Stanford A. Moss of the American firm General Electric invented a two-stage turbine called the turbo supercharger, or simply turbocharger, though this was not intended for powering vehicles directly. Rather, the turbocharger used waste energy from a conventional piston engine's exhaust to feed more air into the engine's intake manifold, increasing its power input. 2 decades later, this innovation would prove vital to the Allied strategic bombing campaigns over Western Europe and Japan. However, none of these early gas turbines were suited to use in aviation. For the technology to become a truly viable form of propulsion, a number of different technical problems had to be first overcome, such as finding materials heat-resistant enough to prevent the turbine blades from distorting or the combustion chamber from burning through, while simultaneously being lightweight enough to mount in an aircraft. Now, as we've covered many times on this channel, few truly groundbreaking innovations are the product of a single brilliant mind. Rather, they are developed over many years or even decades by dozens of hardworking and often overlooked individuals. But while the jet engine is no exception, it would likely not have been developed or adopted as early as it was were it not for the contributions of two key figures who both came up with the idea at around the same time and unwittingly found themselves in a high-stakes race to get their groundbreaking inventions into the air. These extraordinary men were Sir Frank Whittle and Hans von Ohain. Frank Whittle was born on June 1st, 1907 in Coventry in England, the eldest son of mechanic Moses Whittle and his wife Sarah Garlick. Fascinated by machines from an early age, Whittle learned about practical engineering by helping out in his father's workshop, and in 1923, at the age of 16, he signed up to join the Royal Air Force as an aircraft apprentice. Unfortunately, he was rejected when his short height and slight build caused him to fail his medical examination. Determined to join up, he embarked on a regimen of intense physical exercise to bulk himself up and applied twice more, once under an assumed name, before finally being accepted. He was then sent to No. 1 Squadron of No. 4 Apprentices Wing at RAF Cranwell for a 3-year course in aircraft maintenance. To Whittle's dismay, he soon discovered that the strict RAF discipline was not to his liking and that his physical limitations made his becoming a pilot an unlikely prospect. He grew so depressed that he seriously considered deserting, only keeping up his spirits by joining the Model Aircraft Society. Then, in 1926, the quality of Whittle's models so impressed the commander of the apprentice wing that he recommended him for officer training at RAF College Cranwell. Here, Whittle finally got the chance to take flight training, soloing in 1927 after only 13.5 hours of instruction. He soon became an accomplished pilot, gaining a reputation for daring stunt flying. As part of his officer course, Whittle was required to prepare a thesis, which he decided to write on future developments in aircraft technology. Whittle calculated that an aircraft could achieve maximum range by flying at high altitudes, where reduced air density results in less drag. However, the physics of propellers and piston engines meant that at such altitudes, the aircraft's performance would also be reduced. It was while pondering this problem in 1929 that Whittle had an epiphany. Why not replace the piston engine and propeller with a gas turbine, which could theoretically produce far greater thrust at higher altitudes? Whittle obtained a patent for his engine design in 1930 at the age of only 22, and his superiors at RAF Cranwell were sufficiently impressed that they arranged for him to present his idea to the Air Ministry. However, as Whittle later recalled, the result was extremely disappointing. The net outcome was a letter from the ministry to the effect that any form of gas turbine was impractical. Indeed, the Air Ministry was so uninterested in Whittle's idea that they allowed his patent to be openly published. As a result, his design soon became known to engineers across Europe, including, fatefully, in Germany. Nonetheless, Whittle continued to develop the design on his own time, though he had so little money that when his patent expired in 1935, he was unable to renew it. But Whittle was not entirely without friends, and in that same year, some fellow RAF officers arranged a meeting between Whittle and Lancelot White of the banking firm O.T. Falcon Partners. As White later recalls, the impression he made was overwhelming. White recalls, "I have never been so quickly convinced or happy to find one's higher standards met. This was genius, not talent." Whittle expressed his ideas with superb conciseness. "Reciprocating engines are exhausted. They have hundreds of parts jerking to and fro, and they cannot be made more powerful without becoming too complicated. The engine of the future must produce 2,000 horsepower with one moving part, a spinning turbine and compressor. White immediately agreed to fund the establishment of a small experimental aircraft company dubbed Power Jets Limited. While the RAF still considered the turbojet impractical for military use, they nonetheless allowed Whittle to pursue the venture provided he spend no more than 6 hours a week on it, an order he flagrantly ignored. Whittle and his assistants set up shop in the workshop of the British Thomson Houston Company, who manufactured the components for Whittle's first experimental test engine, dubbed the Whittle Unit, or WU. Very much a proof of concept, the WU used a single-stage centrifugal compressor connected to a single combustion chamber and a single-stage turbine, the whole assembly being housed in a sheet metal enclosure to catch turbine blades and other components should they fly off the engine. After 2 years of work, the WU was finally ready for its first test run on April 12, 1937. Whittle later described the event thusly. Immediately, with a rising screen, the engine began to accelerate out of control. I promptly shut the valve, but the uncontrolled acceleration continued. Everyone around me took to their heels, except me. I was paralyzed with fright and remained rooted to the spot. A few seconds later, however, the engine decelerated and came back under control. The problem, it was discovered, was a puddle of fuel which had gathered in the combustion chamber during a previous fuel pump test. Whittle installed a drain at the bottom of the chamber and tried again the following day, though this second test was no less hair-raising than the first. To quote him again, "This experience was more frightening than the first because local overheating had caused combustion chamber joints to leak, and the escaping fuel vapor took fire above the engine. Altogether, a petrifying situation, except for those who once more disappeared with record-breaking speed." The quote ends. This time, the problem was found to be a faulty fuel valve. This, too, was easily resolved, and after a few more successful tests, Whittle and his team were ready to demonstrate the engine for Dr. David R. By, Deputy Director of Scientific Research at the Air Ministry. The demonstration, which took place on June 30th, 1939, so impressed By that just weeks later, the Air Ministry awarded Power Jets a contract to produce a new engine designated the W1 for an experimental aircraft to be built by the Gloucester Aircraft Company. The aircraft, known as the Gloucester E-2839 Pioneer, was delivered to the airfield at Brockworth, Gloucestershire on April 7th, 1941. By now a fully qualified test pilot, Frank Whittle performed many of the initial taxi tests himself using a non-flight-worthy version of the W1 engine. Finally, the aircraft was fitted with a proper engine and on May 15th, 1941, flew for the first time with test pilot Gary Sayer at the controls. During the flight, which lasted 17 minutes, Sayer achieved a maximum speed of 560 km per hour, only slightly slower than the RAF's fastest fighter at the time, the Supermarine Spitfire Mark V. But while this was a monumental achievement, it was not the first flight of a turbojet-powered aircraft. Unknown to Whittle, he had been beaten to the punch by 2 years by a similarly brilliant and driven German engineer. Hans von Ohain was born on December 14th, 1911 in Dessau, northern Germany. Like Frank Whittle, von Ohain first conceived of the jet engine as a 22-year-old university student. Otherwise, however, the two men's career trajectories could not have been more different. After obtaining his PhD in physics and aerodynamics from the University of Göttingen in 1933, von Ohain became a junior assistant to Robert Wichard Pohl, director of the university's Physical Institute. In 1936, he patented his jet engine concept and, along with automotive engineer Max Hahn, attempted to build a working example. Unfortunately, von Ohain and Hahn could not get the fuel to ignite and burn stably in the combustion chamber, causing flames to shoot out the back of the engine and the electric starter motor to overheat. Nonetheless, their work soon caught the attention of Ernst Heinkel, founder and director of aircraft manufacturer Heinkel Flugzeugwerke in Warnemünde. On Pohl's recommendation, Heinkel hired von Ohain and provided him with the funding to continue his jet engine research. By February 1937, von Ohain had assembled a new engine called the HES-1, fueled by hydrogen gas. Though the engine ran well, the hot-burning hydrogen quickly damaged the metal components. Von Ohain thus modified the design to run on kerosene, producing the more reliable HES-3, which could produce 4.9 kilonewtons of thrust. To flight test the new engine, Ernst Heinkel tasked his two best engineers, Walter and Siegfried Gunther, to design an experimental aircraft dubbed the HE-178. 7.6 meters long with 7.3 meter long elliptical wings mounted high on the fuselage and a conventional tail dragger undercarriage, the HE-178 was powered by a single HES-3 engine mounted behind the pilot, fed through an air inlet mounted on the nose. The HE-178's maiden flight took place at Heinkel's Marahina Aerodrome on August 27, 1939, just 5 days before Nazi Germany invaded Poland. Present on the field that day were several top officials from the Luftwaffe, including General Oberst Ernst Udet and General Feldmarschall Erhard Milch. Ernst Haeckel later described the historic event. He, test pilot Erich Vorsitz, was flying. A new era had begun. The hideous wail of the engine was music to our ears. He circled again, smoothly and gracefully. The riggers began to wave like madmen. Calmly, he flew around once more, and when 6 minutes were up, he started to land. He cut out the jet unit, then misjudged the approach and had to sideslip. Sideslip with a new, dangerous and tricky plane. We held our breath, but the HE-178 landed perfectly, taxied and came to a stop. A magnificent landing. Within seconds, we had all rushed over to Vorsitz and the plane. The riggers hoisted both of us onto their shoulders and carried us around, roaring with enthusiasm. But Heinkel and von Ohain's glory would be short-lived, for despite having witnessed history in the making, the Luftwaffe observers left the demonstration largely unimpressed. A mechanical fault had forced Vorsitz to fly with his landing gear extended, limiting his top speed to only 598 km per hour, only slightly faster than Germany's standard fighter, the Messerschmitt Bf-109. Furthermore, the rapid advance of German forces across Europe convinced military planners that the war would be quickly concluded, making new aviation technologies like jet propulsion unnecessary. By the time the Luftwaffe changed its mind about the value of jets, other aircraft manufacturers had already leapfrogged ahead of Heinkel and von Ohain's first prototypes. In 1940, for example, designer Anselm Franz of rival aircraft manufacturer Junkers Flugzeug und Motorwerke developed the Jumo 004 engine, which used a more efficient axial flow compressor in place of von Ohain's centrifugal flow compressor. BMW and Brander Buschisch Motorenwerken, or BRAMO, also developed similar engines, while the Reich Air Ministry, or RLM, secretly contracted Junkers, Messerschmitt, and others to manufacture their own jet fighters. Despite being left out of this request, Heinkel proceeded with the development of a twin-engine jet fighter called the HE-280, which incorporated a number of key innovations, including tricycle landing gear and a pneumatically propelled ejection seat, the first in aviation history to save a pilot's life in an emergency. After lengthy delays caused by developmental difficulties with its intended engine, the HES-8, the HE-280 finally made its maiden flight on the 22nd of September 1940, becoming the world's first jet fighter to take to the skies. Subsequent test flights proved the HE-280 to be a superbly swift and agile aircraft, easily outmaneuvering the Luftwaffe's best conventional fighter, the Focke-Wulf FW-190, in mock combat. Nonetheless, the RLM ultimately rejected the design, and a rival firm, Messerschmitt's Me-262 Schwalbe, became the world's first operational jet fighter, entering service in April 1944. Thankfully for the Allies, several factors prevented the Me-262 from having a significant impact on the war. Chief among these was Adolf Hitler, who, believing that Germany should always be on the offensive, ordered that the new jets be used for ground attack, a task for which they were ill-suited, rather than shooting down Allied bombers. And even when the Me-262 was deployed in its proper role as a fighter, technical and logistical problems prevented the aircraft from reaching its full potential. The primitive metallurgy of the Junkers Jumo 004 engines gave them an extremely short lifespan, requiring them to be removed and overhauled after only a handful of flight hours, while Allied bombardment of factories frequently interrupted the production of new engines and spare parts. Worse still, chronic fuel shortages caused the Me-262 squadrons to spend most of their time on the ground. Meanwhile, in Britain, Gloucester developed his own jet fighter, the Gloucester Meteor, powered by two of Frank Whittle's upgraded Powerjet's W2 engines. First flown on March 5, 1943, the Meteor was the Allies' only operational jet fighter of the war, though it never saw combat against manned aircraft. Instead, its 970 km/h top speed made it invaluable for chasing down the German V-1 flying bombs that terrorized southern England between June 1944 and March 1945, with Meteor squadrons scoring 13 victories by the end of the war. And for more on this, please do check out our previous video, A Wingtip and a Prayer, the insane way British pilots defeated Germany's secret weapon. While the Meteor was under development, the British government secretly shipped a Powerjet's engine and a handful of engineers across the Atlantic to the General Electric facility in Lynn, Massachusetts, in the hope that the Americans could improve the design and put it into mass production. The GE team that received the engine was sworn to secrecy, as former engineer Joseph Sirota later recalled, "Our colleagues called us the hush-hush boys. We couldn't talk to anyone about our work. The FBI man warned me that if I gave away any secrets, the penalty was death." Indeed, the project was so secret that no outside contractors could be brought in to modify the workshop or build test stands and other equipment, forcing the engineers to carry out this work themselves. They were also hampered by a lack of adequate tooling. To quote, "Our wrenches didn't fit the nuts and bolts because they were on the metric system. We had to grind them open a little more to get inside." Despite these difficulties, in March 1942, just 5 months after the project started, the GE engineers successfully bench-tested their redesigned engine, the IA, producing 5.8 kilonewtons of thrust. The IA was subsequently installed in an experimental fighter aircraft, the Bell Aircraft XP-59 Air Comet. In keeping with the top-secret nature of the project, during ground handling, the XP-59 was fitted with a dummy propeller to disguise its true nature. The Air Comet made its maiden flight on October 2, 1942 at Murakami Airfield in California, today Edwards Air Force Base, with test pilot Colonel Lawrence Craigie at the controls. Unfortunately, the first American jet proved underpowered and never entered service, though GE would later refine its IA engine into the J-31, the first jet engine to be mass-produced in the United States. In 1945, the Lockheed P-80 Shooting Star became the United States' first operational jet fighter, serving with distinction in the Korean War alongside other early jets like the North American F-86 Sabre. The commercial aviation market followed suit in 1952 with the introduction of the British de Havilland DH-106 Comet, the world's first jet airliner. Within just a few years, the age of piston-engined aircraft had finally come to an end. Jets now ruled the skies, making the globe just a little bit smaller with each passing year. Of course, jet engines have come a long way since those early days, seeing dramatic improvements in thrust, fuel efficiency, and reliability. But, well, that's a story for another time, isn't it? Thanks for watching.